Hi, my name is Yassine Zeroual. I will guide you in this lesson, which is a lesson from CCSP, Cisco Certified Security Professional, Cisco ASA Adaptive Security Appliance, Active Standby Failover Mode. In this lesson, we will cover the following: Active Standby Failover Mode overview, configuring Active Standby Failover Mode with the CLI, configuring Active Standby Failover Mode using ASTM. Here in this example, we have a single Cisco ASA configured with 3 interfaces, inside, DMZ, outside. This ASA is configured with security features and policies to offer a reliable protection as a firewall. Let's say for whatever reason, the ASA goes down. Our goal in this lesson is to find a solution. A common solution for the high availability problem is to eliminate the ASA as a single point of failure by introducing redundancy with 2 redundant ASAs. The 2 ASAs must be identical model, meaning the same hardware. If one ASA fails, the remaining one, the other ASA, will detect the dead ASA peer and be active after 15 seconds by default. Notice that the ASA peer must share identical sets of interfaces. Here each unit has 3 interfaces, inside, DMZ, and outside, and the similar interfaces must be connected together. The inside interface, gigabit Ethernet 0/0 of the primary, is connected to the switch that is connected to the inside interface of the secondary ASA, and the same thing for the other interfaces, DMZ and outside. That's because we want the standby unit must be ready to take over handling traffic inspection at any time, so its interfaces must be connected and ready to use. That's why the 2 ASAs monitor each other's health by communicating over each of their interfaces. We need also to connect 2 interfaces, one for LAN failover gigabit Ethernet 0/5 and one for state failover gigabit Ethernet 0/6. If we want to connect the 2 ASAs directly, we need a crossover cable. Why we need those 2 interfaces, LAN failover and state failover? LAN failover interface is necessary because any changes made to the active ASA automatically get replicated to the standby ASA. State failover interface, it is optional. This interface is used to inform the standby units about the building and tearing down address translations and connections, and also it is used to pass connection state information between failover peers, so that the standby unit can keep its translation and connection table in sync with the active unit. So the role of the state failover interface is for stateful replication. For UDP flows, TCP flows, routing information, I will show you the full list at the CLI using show failover command. Now we did see the cable. Let's move to the next slide. Active standby failover mode overview. Cisco ASA support 2 forms of failover: active standby and active-active. Active standby failover mode means one ASA takes on the active role handling all the normal security functions. The other ASA stays in standby mode, ready to take over the active role in the event of a failure. The active standby failover mode provides device redundancy. Before describing the active-active failover, I want to mention something. One of the requirements of active-active failover is to convert the ASA from single mode to multiple mode. In multiple mode, you will logically carve up or split the ASA into 2 or more logical firewalls. It is also named as context. And in multiple mode, there are some features that did not work. For example, you cannot run dynamic routing protocols in multiple mode, meaning you cannot run OSPF, EIGRP, and RIP in multiple mode. Active-active failover mode is when the ASAs are running multiple security contexts. The contexts can be organized into groups. One ASA is active for one group of contexts, and the other ASA is active for another group. In effect, both ASAs are actively involved in providing security functions, but not in the same security context simultaneously. The active-active failover mode provides both device redundancy and load balancing across contexts. Here in this lesson we have ASA is implemented, NATs in place, access control list in place, modular policy framework in place, everything is okay. In this example we have fault tolerance. In case the primary ASA fails, then the secondary ASA becomes active in 15 seconds by default. In this example, the end user can access the internet even if one ASA fails. Let's say the primary ASA, which is the active ASA, fails. So what happened during failover? During failover, the ASA swap MAC and IP addresses, so that the active unit always uses consistent and predictable values regardless of which physical unit is active at any time. If a failure is detected on the active unit, in this case the primary unit, the two ASAs effectively swap roles. So the secondary becomes active and the primary becomes standby. The ASAs not only swap the role but also swap the IP addresses and MAC addresses. If failover happens, the normal routed interfaces, I mean inside DMZ and outside interfaces on the new active unit, will use the system IP addresses and MAC addresses. Always the active ASA will use the system IP addresses and MAC addresses. For the LAN failover interface and state failover interface, never swap their IP addresses or MAC addresses. When the secondary ASA becomes active, he will do a gratuitous ARP, so the switches will figure out where that layer 2 address lives. So the ASA, after being active, he will inform the switches by its MAC addresses and IP addresses, which are the IP addresses and MAC addresses of the system. I did capture the traffic in two scenarios. The first scenario, I did swap the roles. I did capture the traffic between the secondary ASA, interface gigabit Ethernet 0/0 inside, and the switch. Using Wireshark we have 6 packets, 3 for gratuitous ARP for 192.168.1.1 and the other 3 for gratuitous ARP for 192.168.1.2, and you can see the details here: sender MAC address and sender IP address. For the second scenario, I did shut down the ASA. So we have only 3 gratuitous ARP for 192.168.1.1, and you can see the details below: the sender MAC address and the sender IP address. That's happened behind the scene, and the end user can still access the default gateway with the same IP address and browse the internet and not even notice there is a problem. The ASA configurations are always maintained on the active unit. As you make changes to the running configuration, the commands are automatically synchronized from the active unit to the standby unit. You can force the running configuration synchronization by entering the write standby command on the active unit. The startup configuration, however, is not automatically synchronized. The copy running config startup config command saves the running configuration to flash memory on the active unit and then to the flash on the standby unit. Each ASA maintains its own flash file system, but files are not replicated between the units as a part of failover. This means that each ASA maintains its own operating system and ASDM images. Now I will go to the lab to do the configuration using CLI. Let's first ping the public DNS 8.8.8.8 from a PC inside the LAN. Yes, we can ping. I did enable the inspection of ICMP at the ASA, so the ping can pass through the ASA from inside to outside. We cannot ping from outside to inside. First of all, we need to enable the two interfaces that we will use for the LAN failover Gigabit Ethernet 0/5 and for state failover Gigabit Ethernet 0/6 by issuing no shutdown. Now I'm telling the ASA, 1, you are the primary. Now I will enter the key for failover 1 from 1 to 6. It is used to encrypt the conversation between the active and standby. To replicate the HTTP connection state information, I did enter this command, failover application HTTP. Now I will configure the inside interface, which is Gigabit Ethernet 0/0. Then I will configure the Gigabit Ethernet 0/1, which is the DMZ interface. Then I will configure the interface Gigabit Ethernet 0/2, the outside interface. Now it's time to turn on failover. At the end of the configuration for the failover at the primary ASA, the command is failover. Now I will start the configuration at the secondary ASA. I will clear all the configuration at the secondary ASA to start from scratch using the command clear config all. then I need to turn on the interface Gigabit Ethernet 0/5, which is used for LAN failover. Here I will configure the ASA to be secondary in failover and give it the key of failover. Then I will need to configure LAN failover interface, and that's it. Now I will turn on the failover. You can see now the secondary is automatically start looking for the primary. After seeing each other, the active ASA will start the configuration application with the standby ASA. And this is the end of configuration application. Due to the configuration being replicated, the default host name will be the same for both the active and standby units. So to know the state of the ASA, whether it is active or standby, and also to know the priority of the ASA, whether it is primary or secondary from the host name, we need to issue one command. Of course, at the active ASA, which is prompt hostname priority state. Now you can see this is the primary and the active, the state is active. Here you can see this is the secondary and is standby. To see the failover details in the unit, you can issue this command, show failover. Here you can see failover is on, failover unit is primary. You can see here the settings for the failover LAN interface, which is Gigabit Ethernet 0/5, which is up. The name is failo. Unit pole frequency is 1 second, hold time is 15 seconds. Interface pole frequency is 5 seconds, hold time is 25 seconds. This host is primary and is active. You can see the interfaces inside DMZ and outside are normal and monitored. Only the interface management is waiting because it is not participated in this failover. The other host is secondary and is standby. You can see the details. This is the stateful failover logical updates statistics. You can see the details here for UDP connection, TCP connection, the routing. To switch the role between the primary and secondary, we can do that by issuing this command, no failover active. Now primary becomes standby, and the other ASA, which is the secondary, it becomes active. I will check if I can ping the public DNS, which is 8.8.8.8 from a PC inside the LAN. Yes, we can ping to public DNS through the active ASA, which is the secondary. If we want to enforce the replication between the active ASA and the standby ASA, we can issue this command, which is write standby. This command will begin the configuration replication with the mate, which is the standby ASA. We can do configuration only on the active ASA, and it will be replicated automatically to the standby ASA via LAN failover interface gigabit Ethernet 0/5. Here at the time recording, I'm using the latest version of the ASA image and the latest version of ASDM, Adaptive Security Device Manager. ASA version is 9.81 and ASDM version is 7.82. We can configure the active standby failover using the wizard or manually. At the setup tab, we can enable failover. I can also enter a shared key to encrypt the conversation between the active ASA and standby ASA. We cannot concurrently configure the shared key and IPsec pre-shared key. Here we can configure LAN failover interface, which is necessary. Select the interface, enter the active IP address, standby IP address, also enter the subnet mask and the logical name. Then we can choose the role, primary or secondary. Then optionally we can configure state failover interface, enter the active IP address and the standby IP address and subnet mask and also logical name. Here we can also enable HTTP replication, because if it is not enabled, the HTTP connection state information is not replicated between the active and standby units. At the Interfaces tab, we can define interface standby IP addresses and monitoring status. It is self-explanatory. By default, every ASA interface will be monitored to detect a failure that might trigger a failover. At the Criteria tab, here we can define the criteria for failover, how many interfaces must fail to trigger the failover. For the failover poll times settings, unit failover is the amount of time between hello messages among units. The range is between 1 and 15 seconds. We can select to be in millisecond, which is between 200 and 999. For the unit hold time, the default is 15 seconds. After this time, if the standby did not receive any hello message, it considers the active ASA as a dead pair, and the standby will swap the role and becomes active. We can select also in millisecond, which is between 800 and 999 milliseconds. There might be some false positives going on. My recommendation is to select it in seconds, and the default is 15 seconds, which I recommend. Monitored interfaces, which is the amount of time between polls among interfaces inside the MZ outside. For the link state, each ASA in a failover pair checks the link state of its interfaces every 500 milliseconds by default. If you minimize it, then the ASA can detect interface failure and trigger failover faster. It is new option, not available in old version of ASA. Interface hold time. After this time, if the data interface did not receive hello message, then the ASA peer is declared failed. Here we can optionally hardcode the MAC address of the ASA interfaces. By the way, we can also hardcode the MAC addresses using the CLI or at the interface settings using ASDM. We can monitor the status of the failover by going to Monitoring Properties Failover Status. Here we can swap the role of the ASA from active to standby, reset failover, or reload standby. To wrap up this video, we did cover the following. CISCO ASA support two forms of failover: active standby failover mode and active failover mode. We did cover active standby failover. In this mode, the ASA takes on the active role, handling all normal security functions. The other ASA stays in standby mode and waits to see if the active ASA has failed. If the active ASA has failed, then the two ASAs swap roles, so the secondary ASA becomes active and the primary becomes standby. The ASAs not only swap roles but also swap the IP addresses and MAC addresses. We did see the configuration using CLI and using ASDM. I hope this is informative for you, and I would like to thank you for viewing.